Identify cis-trans isomerism of a given structural formula. Okay, so the question is, identify whether the following structural formula contains cis-trans isomers. Okay, so first of all, you are given a compound, organic compound. So what you need to do is, you need to draw the structure first. Okay, now when you draw the structure, I would like to recommend that what you do is focus on the double bond side. Okay, then what you do is you categorize them or you group them into 4 groups. Okay, 2 groups for each carbon. Okay, then what you do is, let's look at the carbon double bond. Okay, you can see that 2 different groups are attached to each carbon. Okay, these 2 groups are different. Okay, however, you still have hydrogen here. Okay, they have the same hydrogen. Okay, so they have 2 different groups, but the similarity is they have 1 hydrogen that is the same. So it has cis-trans isomers. Okay, now if let's say this question, okay, now the next part of the question is draw the cis-trans isomers, if any. Now if we have cis-trans isomer, usually the weakness of students is that they don't know how to draw the line between carbon and the groups. Okay, for example, CC double bond, no problem. Okay, but if this one, you can see the carbon is attached to CH2, not CH3. So when you draw, you must draw attached to the CH2, and it is not attached to the hydrogen or attached to the CH3. It is attached to the CH2. Okay, next one is the same. Carbon is attached to the CH2. Carbon attached to CH2. Okay, so same go for this one. CH2, CH2, OH. Okay, now next one. How about Roman 2? Is there any cis-trans? No. Okay, because there are 2 same groups that attach to the same carbon. Okay, here we have 2 different groups, but remember there must be at least 1 same group. Okay, so this is the one for the double bond cis-trans. Okay, now let's look at the cyclic one. Okay, if the cyclic one, if this is a skeletal structure, we know that at the end, it must be CH3 here. It represents CH3 here. Okay, so if we want to identify whether there is any cis-trans or not, so remember carbon must have 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then to find out whether there is cis-trans or not, straighten the line. Okay, straighten the line. Okay, straighten it. And then you will find that, okay, there are cis and trans isomers. And please remember to label them. Okay, so students make mistake. Where do students make mistake? Because they simply put the substituent. The original one is carbon number 1 and carbon number 3, but students put carbon number 1 and carbon number 4. So it is not a correct structure at all. Okay, now let's look at number 2. Is there any cis-trans? Okay, so what we do here is write down what we have. This is CH3, if skeletal structure, CH3. Then this is also CH3. Okay, now we have 2 same group attached to the same carbon. So there will be no cis-trans. Okay, so the part that I would like to highlight for students is must remember to write cis and trans isomer. And then for cyclic, don't forget to identify the number of carbon that has the substituent. Okay, and then for double bond, and then another one, remember to straighten the line when you want to draw for cyclic. And then for the double bond, it's easy only. Divide them into for groups and make sure that you know the carbon is bonded to which atom. Don't just simply attach to hydrogen or any other carbon. Okay, so that's all for cis-trans isomers.